Yeah.
Okay, right. So opening up this, you've not done a refinement of this yet, because I don't see, there should be other reflections underneath here, but there aren't any. Okay. The other things that are an issue here are that you've used this at symbol.
Yeah.
This at symbol means that those parameters are refined. Okay, those 90-degree angles should never be refined. Okay. Right, in here then, I think we probably need to do a C, so that's a smaller C with
Fine.
that. But anyway, you've import the XYE so we can go and see how this runs. Okay, so right. Right, so you can see here that this is really broad.
Yeah.
These peaks are really, really not very sharp at all. Okay, what the issue there is that the the in here, these peak shapes are really, really broad. Right, make sure that your background's all in one line. It helps. What I'm going to do here is I'm going to just replace this with some peak shape, peak type here. I'm just going to redo that. Okay, so it's back to where it initially is. The problem is that we've got the background that needs sorted out first because there's a big hump in it. What I'm going to do is I'm going to take out all these
Out.
because I don't want this to be refined. Okay, right, and I don't want the lattice parameters to be refined either. So if we do that again, what hopefully it's going to happen is the peak shapes a lot sharper now. Okay.
Yeah.
What it's done is it's helped sort out the background much better. Okay, so all I've done there is refine the background, and if we click on yes, okay, what you'll notice now is that the background is now not 0.
Yeah, it is.
There's some sort of 0 thingy in here. This 0, you'll see that that's been refined as well. And the question is, why is that? It's because we've got a parameter name in here. If there was no name in here, we would just have an at symbol like you would be doing down here, okay? Below here, I knew you hadn't done anything with this file because it didn't have these HKL files associated with it. But what we've got here is a good background. Okay, it's a really nice background, and the peaks are roughly where they should be. Okay, but they're not quite there yet. Okay, why is that the case? Okay, the reason that they're not quite there yet is because we've locked in our unit cell parameters. Okay, because we have not refined our crystal structure, refined the lattice parameters, the unit cell parameters, it means that they can't shift left and right. Okay, remember the poly fitting, we're taking the X, the Y from the actual pattern itself. Okay, so by refining the crystal structure, all we're doing is going to be doing this and making sure that they fit properly. Okay, so background first with everything pretty much locked down. Then you can open up the unit cell parameters and start refining them, and then we do peak shape. Okay, so peak shape is kind of the last thing we start to refine. Okay, so by doing that, we're actually in a reasonable place. You can see that we're static, we're not moving anywhere. This is the best we can possibly get at.
Okay.
And the reason is because our peak shape's not quite right. Okay, what we can do, and I hope this works, is that we can then start to let these go a bit.
Fine.
Okay, so what we've done is got the right peak shape, and now we're just going to let it go like this. Okay. Now if we do that, it's going to start creeping up. Not quite there yet. Okay. Okay, that's not worked particularly well. Okay, so we need to think about this a little bit better. Okay, so what I'm going to do is I'm going to just take out that peak shape, and you can see what that does to the shape of the things. You can see it's far sharper now,
Yeah.
and we'll just go with that for the moment. Right. Right, what I'm going to do is I'm just going to take out this one for the moment. I'm going to take that out for the moment. I'm just trying to get rid of parameters that might cause issues. Okay, so we'll see where it's sharpened it up a wee bit more even. Okay, so we can refine that. Okay, and then what we can do is open that back up again. And that, okay, so
Fine,
that simple axial mode is a challenge. Okay, so what I'm going to do is I'm going to take, so that's gone up to 44. That's obviously having an issue with the peak shape. The peak shape and the axial mode are linked together with one another in terms of what they're able to do. So what I'm going to do is I'm just going to go and pop that back in, okay, and delete this one. Okay, so it's giving me a reset value. Okay, and now I'm kind of fit properly with our data. I can then.
Yeah.
Okay, so you've kind of you drifted so far away with that axial mode. We went out to 44, which is not reasonable. Okay, this has come down to a more reasonable value. Okay, so if you the first thing you want to do is do the background. You can do a bit of a zero error if you want. It's not going to change that much.
Yeah.
But then get all your model correct first of all. Your parameters here correct, and then you can do other things. But it's a question of how much you can get from this data that you've got here.
Fine.
So it's quite hairy. The background's quite hairy, so you've not collected it for long enough, I don't think. It's quite a quick scan, or not enough material, either way. But what you've now got is a 11% R WRP for your system, 10%, and it's a well-fitting model.
Okay, but the thing.
So that's you've put in that. Okay, now just go down each of these. So which one did you use before?
D500.
This one?
Yes.
Okay, so that's you just got your material.
But like here I need to adjust this because I was using Priscilla and this is the monochromator. So 0.
So that needs to be 0? Okay,
yeah, okay. Fine. Yeah.
If that's what you need to do, then that's fine. Okay? Okay.
And then the structural information.
Okay, so you can either do it from here, okay, so that's just this. Oh, so this is Durham menus. This is just your Topaz. So this is probably a bit more extensive. Durham have filtered it down to commands that are usual. Okay, so this is Durham School.
Fine.
So there's a crystallography school.
So you do from Topas?
You can do it from here if you like, but it doesn't matter. The same sort of stuff comes.
Okay, fine.
So here you've got your structural information here.
Yeah.
You've got your phase name, which we'll just call blah for the moment. Okay. Then we've got our lattice parameters. Okay, so
triclinic.
And that's where you need the other file. Okay, so if I go back to is this the same file? Yeah.
No, that is different.
It's different. Okay, so what have you got the? Okay, so if we do that, then we can do triclinic in here. Okay.
Yeah.
Have you got a CIF file for this? What are we wanting to put in?
I'm with WFJEP from the literature.
So it's the WFJEP. Okay, well, it doesn't matter then, right? We can just do this.
Okay, yeah.
It honestly doesn't matter where you get your lattice parameters from.
Okay.
You need to consider, if things don't go your way, you need to think about effects of temperature and so on and so forth. But this is not triclinic, by the way.
Okay.
This is,
Sorry.
this is a monoclinic system, okay? Now, what I'm going to do is I'm going to take out these, because obviously they're causing an issue to begin with. Okay, so all I've done is put a mark next to them to make sure they don't get used. Okay?
Fine.
This is us, right? This is
Yeah.
us ready to go. You can see the input space. You need to make sure they're in quotes like this.
Okay.
And it is big C
C.
centering, P centering, I centering, F centering. All of that is capital.
Fine.
Any glides that you have or mirrors are all lowercase.
Fine. Yeah.
Okay. And this really should be it.
Yeah.
Okay, so we can just save this. Open up Topaz. Okay, and rockets. Okay, I'm gonna go back, double check. Right. So what I don't want to do at the moment is I don't want to be refining this at the moment. Okay, this should give me a good enough placement. Okay,
Fine.
but I'm trying to limit. All I want to know is whether the background's going to be bad or not. Your other background was really high and going down low. Let's just get the background sorted out, and then we can add in more parameters.
The picture, fine.
Okay, because if you add in too many parameters at the beginning, it can cause issues. Okay. Right. Boom. Okay, so you can see that our background here is reasonably well fitted. Okay, it's okay. There's a little bit of a hump here that we need to worry about. Okay, if we go back to our background, it's only closed. Right. What we'll want to do is maybe want to add in a few knots. Okay.
Fine.
And then try that again to see whether it does this a little bit better. Right, so it seems to be fitting that background a little bit better.
Fine.
Now you can see the difference curve is bad at the moment.
Yep.
So we're obviously not hitting the correct mark for our lattice parameters. We're not in the right sort of place. Okay, so what we'll do is we'll click on yes. What that's done is it's updated your background.
Yep.
Okay, and now what we'll do is we're going to go and do your refinement of your unit cell or lattice parameters. Okay. We can click on Topaz again, and we can go. Right, has that changed?
Not bits like, but still, the peaks like they were fitting before, and now it's going.
Yeah. Okay, so it's not really fitting for some reason or other. Okay, so we can click on yes. What we'll have done is, because we've refined the lattice parameters, these are now looking as though they've been refined. The issue we've got here, okay, one thing we haven't put in here potentially that might help us is if we select in 0.
Okay, yeah.
Okay, so a 0 error just allows it to wiggle a little bit, and allows if you're just a slightly bit off, then it might help cure it. Okay, so it just adds in a default. I'm going to shift my pattern up this way or this way.
Okay.
Okay, so the pattern won't change, but it might just help it, right? So it's not done anything at all.
Yep.
Okay. We can click on yes. Now the question is, why is this not happening? Now it's not happening because this peak is off.
Yeah.
Okay, this peak is not really conforming. This peak is not really conforming.
Yep.
One of these ones here is not really conforming, and so forth. This one isn't either. Okay, so you can see that this is possibly going to be your 020 reflection. Okay, that is just too low in too high in D spacing.
Fine.
It needs to be a bit lower. Okay, so what we can begin to do is actually fudge this out a little bit. So what was it? 2. Right. What I need to do, because I think it's going to be the 020.
Yeah, 020. Yeah.
Right. That's 4.53. Multiply that up by 2.
Okay, so that should be 9.
906.
Yeah.
Okay, because this is the beta angle, the B, right?
Yeah.
If you can imagine your unit cell, your A and your C, your B direction is this one here.
Z. Yeah.
If you change the B length, is that going to be an issue? Is it going to have to right, in the B's pointing up here, all we're doing is going to change this length. Okay, now the angle here, so this is the A and the C, and so this is going to be the C to B, which is the alpha angle.
Yep.
Yeah.
Yeah.
A and B.
B.
So this is the gamma
Angle.
here.
Yeah.
So this is already going to be 90 degrees.
Yes.
If I extend it, go up or down, it doesn't matter.
Yeah.
Okay. If it's the B direction, I can just do that, and that's what I'm going to do now. I'm just going to extend that out or reduce that down. So it needs to shift to lower despacing.
Fine.
Okay. So we said, what was it? 06?
9.6.
06 or something like that.
Yeah.
Okay. And if I send that and move and go. Okay, so that's moved that up a little bit. You can see that's gone up slightly. The impact of that is it's slightly moved that up a wee bit.
Yes, yeah.
Impact of that, what's this one? If you click on yes, just for the moment. If you click on that one there, 040. So it's not quite, that's not affected by our B direction.
Exactly, yeah, yeah.
We need to play around with the A direction. Okay, now 9.336, multiply that by 4, what's that, 36 point something?
Yeah.
Problem is, if conversely we do it, we go B and C, A is out like this.
Yeah.
So if I elongate or shorten that, it is now going to be
as well.
in fact impacted by the beta angle as well.
Yeah.
Okay.
Yeah.
So there's you need to have the change, but you need to factor in a sine of the beta angle as well.
Okay, fine. Yeah.
So we need to kind of think about that. Are you going to do that in reality? No.
Yeah.
I just want to move. I want to push my A-axis just a wee bit up this way. That's what I want to do. So if we look at down here, I'm here. I just want to move it this way a little bit. Okay, so in reality, what am I going to do? I'm just going to move it to slight that way a little bit. So I'm going to delete and put in 2.6.
Okay,
4.6 to 2.6.
Fine.
Okay, that's practically what I'm going to be doing at the moment. Okay, and if I do that, if we look at that, it's moved up a bit.
Exactly, yeah.
Okay. Has that impacted this one? Has that impacted this one a bit? It will have done. Both of those, because that's got an A component and a B component. It will have affected this a little bit.
Yeah.
Right, now if we unzoom this and have a look at all the other patterns, okay? So we are getting better at this one. Okay, this one's ever so slightly better, so that's 2.0, okay, so that makes sense.
Yeah.
Okay, but we need to try and get the other ones, see how the other ones go. Now, what at the moment we're doing is we're just using our intuition and trying to move these parameters around.
Yeah.
See, this one's off a bit, that's 0.2, so we've not done anything about the Y component yet. If we had an individual Y component, well, so there's an individual X, that kind of works. Have we got an individual Y component? Then that would be, oh, there we go, right? The 0.20. Okay, so we can go down there. 0.20. Okay, let's move this a little bit up that way. If we're moving it up in angle, we need to move this down. So let's move that down to say
6.
6. Okay, let's put in 6 and send and go. Now all we're doing is tweaking these a little bit, so that's a reasonable effort with that.
Fine.
Okay.
Yeah.
Now what does that look like in terms of the rest of the pattern? Okay, we're large. You can see they're being masked largely. What you can now do is you can now use the peak shape to your advantage, because peak shape will start to do this.
Yeah.
Okay,
and then
it will start to graduate. So if you allow it to move in X, but also allow it to do this, it will sort of morph and dance its way into hopefully the right place.
Fine.
Okay. So all I'm going to do is get the unit cell parameters going as well as the peak shape.
Oh, okay, yeah.
Yeah. So
Yeah.
you've been able to sort of work your way through just by moving this a little bit and changing this
Yeah.
ever so slightly. Okay. Now the other thing that we haven't done here yet is we've factored it out, but it may be that this simple axial mode is also going to help contribute to this as well, because we've mentioned that previously. Okay, and if we click on that,
Yeah.
it's got even tighter.
Yes.
See how?
Yeah.
So a little bit of manipulation of the unit cell, then using the peak shape, we've been able to get to a position where we're much better. Now, is this a good model? Is this a good fit?
But still, like, it have the different peaks at the bottom.
But what have we got? What are we trying to do?
We are trying to fit the data against the model.
Fit the data against the model?
Model like against our data.
Right. Okay.
Yeah.
And what has our data intrinsically?
Uh,
What does our data have intrinsically?
that is dihydrate.
No, but in terms of any data that you collect, what is an issue with data that you collect?
Because like that is the single crystal we have like we are trying to adjust our unit cell parameters against that is the single crystal, and being collected at a different temperature, might be at a low temperature, that also put a factor. And plus
Yes, that's the model. You're still talking about the model there, but what's the issue with the data that you collect? Any data that you collect, what is there?
sorry, I'm not getting.
Okay, so any data you've got has got some sort of experimental error.
Yeah.
Okay, so there's an experiment. The way it's integrated, the way it's collected, there'll be small errors.
Fine. Okay.
Okay,
Yeah.
so if you look at, let's go and take this specific one here. You can see, this seems to be a little bit more of a peak shape error.
Yeah.
So, in terms of the diffractometer, the way in which you can imagine it being a Gaussian peak. It's not a Gaussian peak. We've changed it to have this what is it? TCHZ peak type. Okay, that's what the type of peak it is. So that's the shape. It's not a Gaussian curve. It's got this shape to it.
Fine.
Okay, and it's always going to have that sort of these sorts of things. This sort of error, this up down. That's a sort of fitting of the peak position. Okay, and so you can. I'm not saying get away with, but this is a reasonable fit to your data.
Okay.
You know, a large portion of your peaks are fitting really rather well. I can see it. I mean, there are small shifts here that are an issue, but that might be associated with the type of peak shape we did. If, for example, we took the model, if the diffractometer was characterized properly, and you had a model for the peak shape for the diffractometer itself, then that might give you a better peak shape than this. Okay, so what they should have done down there is to have silicon, okay, as a standard.
Yeah.
Okay, they know what the unit cell parameters are. Then the diffractometer is used to collect that silicon.
Fine.
Okay, if you know what the silicon is, you know what the unit cell parameters are, then you can start, you know what the unit cell parameters are, you can lock them in place.
Okay.
Then you can model the peak shape of the silicon, because you know your silicon's a standard, it's good.
Exactly.
Then what you're doing is, what you're probing with that movement of the peak shape is that you are now characterizing your diffractometer.
Fine. Yeah.
So if the silicon is doing that peak shape, then every single sample should have that intrinsic peak shape.
Yes.
The sample might add in a little bit more.
Yeah.
But in general, it will have that basic shape, but then your sample adds in a little bit more to it. And that's where this adds a little bit into it. We've not really modelled particularly the diffractometer here.
Yeah.
Okay, this simple axial mode is sort of doing it, but that's it.
fine.
Okay, so if we have a better error model and a better intrinsic model for the diffractometer, then these peak shapes should become a little bit better.
Okay, fine. Yeah.
But that is for me, that's a pretty decent fit.
Okay. Yeah.
There are no missing peaks here. There's no phases missing in this in any way, shape, or form.
But
This
then
is all peak shape.
there is